Ratio Module 2 Lesson 4. Welcome back, students. Solving word problems involving two pairs of ratios. Calculators are allowed. Okay, sometimes we are given two separate ratios involving three different quantities. We've got to find out how they work and how to use this knowledge to solve word problems that involve two pairs of ratios. Objectives of this lesson. Objective number 1, combining two pairs of ratios for three quantities. Number 2, solving word problems involving two pairs of ratios. Sounds difficult, I know, not to worry, we'll take it one step at a time and we will conquer this. Let's look at question 1, students. Given that A is to B equals to 5 is to 2 and B is to C equals to 3 is to 1, find A is to B is to C. Now this is what we were talking about. This is the part where we have to learn how to systemize the way we work. So let's look at step 1 and let's write the information given to us in a systematic manner. A is to B is to C. Let's write that down. A is to B is to C. Right? Draw a line below that. Okay, the first information given to us, A is to B, right? That is 5 is to 2. The next information given to us is 3 is to 1. So what do you realize here? You have the values for B given to you. Both the values are given. 2 and 3 are given to you. So we need to find the lowest common multiple here so that we can convert the other two units. What do you realize the common multiple is? 6. So when you rewrite the entire thing of A is to B is to C, B's value becomes 6. So let's write this first. Again, how it could possibly look. A is to B is to C. Again, we write that. Let's write the values for B first, 6 and 6. Because this is the common multiple. So from here, from the first step over here, hold on for a while. Let me use an arrow to illustrate this, right? From here, to get to 6, what do you have to multiply it by? You've got to multiply it by 3. Right? Now for the one below, the other value, from there, see the 3 over there? To get to 6 again, you have to multiply it by 2. And what did we learn in ratios? When you multiply one number by 3 or 2, you have to multiply every number within that specific ratio. So if you multiply 2 times 3, you have to multiply 5 times 3 as well. So 5 times 3 is equals to what? 15. For the second line, you multiplied it by 2. So you've got to multiply 1 by 2 now. 1 times 2 is 2. So now you draw the ratio together. 15 is to 6 is to 2. And that is your final answer. It all revolves around B's values because both the values for B is given. Then you have to play around and find that relationship. Understand the concept and all the other questions will be easy for you. Okay, this is going to be an interesting one. Question 2. Okay. A is to B plus C equals to 1 is to 4 and A plus B is to C equals to 7 is to 3. Find A is to B is to C. Now I know, the first look at this you might think, oh my goodness, this is really difficult. But let's simplify this. Once again, get systematic. The most important thing to note here is the total value of A plus B plus C will never change. It will be the same. So again, let's write it out systematically. A is to B plus C is to total. Why are we calculating the total here? Because that is going to help us out in getting the final answer. Okay? A is to B plus C is to total is 1 is to 4, right? This is information given to us. 1 is to 4 is to total is what? 1 plus 4, 5. On the other side, we have A plus B is to C is to total. Draw a line underneath that. This is information given to us. 7 is to 3. You add that up and you get the total 10. So the totals are important figures here. On one side you have 5, on the other side you have 10. So for you to make that 5 into a 10, you multiply that by 2, right? So the common multiple is what? 10 units. So multiply everything by 2 and you get 2. On the left hand side you get 2 is to 8 is to 10. So the total becomes 10. On the right hand side you get 7 is to 3 is to 10. The numbers don't change. The beautiful thing here is the totals now match up. The totals become the same. Now it's easy. Now you can work it all out. What is A? Look at A, you get the answer from step 2, which is 2. A is 2, right? What is B? We leave B out for a while. Let's go to C. You get C is 3. So what is B? You take the total, you subtract it by A and C, which is 2 and 3. So 10 minus 2 minus 3, and you get 5. You get B as 5 as the as 5 as the answer. And that is your final answer. You're done with it. It looks difficult, but remember, do it systematically and you get it always right. Question 3. The ratio of the number of pies to cakes in a bakery is 5:4. The ratio of cakes to buns is 6:11. If the total number of pies, cakes, and buns is 245, find the number of buns in the bakery. So the final information that we are requiring here is to find the number of buns. Step 1. Now we know that the first step is to always write the information in a systematic manner, and then we find the common multiple, right? So let's do this. Pies is to cakes is to buns, which is pies is to cakes is what? 5:4. Cakes is to buns is 6:11. We have both values for cakes. So we need to find the common multiple there. The common multiple seems like 12. So we write 12 over there first. As far as the ratio of 5:4 is concerned, from 4 to get to 12, you multiply it by 3. Therefore, 5 is also multiplied by 3, where you get 15. 15 is to 12. As far as getting from 6 to go to 12, you multiply that by 2. So for 11, you multiply that by 2 as well, and you get 22. So you've got the ratio sorted out here. So now that you have the ratio sorted out, it's easy for you to calculate the number of buns. And for that to happen, we move on to step 2. You have to know the total number of units. What is the total number of units? 15 plus 12 plus 22, which gives you 49 units. Now these 49 units are represented by 245 pies, cakes, and buns. If 49 units is equals to 245, 1 unit is equals to 245 divided by 49. When you do the math, you get the answer is 5. So if 1 unit is equals to 5, 22 units of buns will be equal to 22 multiplied by 5. And the answer you get is 110. So that's the number of buns you have in the bakery, 110. Final answer. Question 4, students, is an interesting one. On sports day, SCORE campus pupils were equally divided into 2 teams. Keyword equally. Team A was made out of boys and girls in the ratio of 5:1, and Team B was made out of boys and girls in the ratio of 3:5. What is the ratio of the number of boys to the number of girls at the SCORE campus sports day? Step 1. Since the pupils were equally divided into the 2 teams, this means that the total value of both ratios are the same. So let's write it out systematically like we always do. And that makes it very, very easy. Team A. Now B represents boys, G represents girls. So B is to G is to total, okay, which is T, which is for Team A is 5:1 is to 6. For Team B, B is to G is to T is 3:5 is to 8. Now, to make both totals the same using their common multiple, the lowest common multiple, in this case is going to be what? In this case is going to be 24. So how do you get from 6 to 24? You multiply by what? You multiply by 4. So when you multiply 6 by 24, 6 by 4 you get 24. Then you multiply 1 by 4, you get 4. Then you multiply 5 times 4 and you get 20. On Team B side, you take 8 and you have to multiply it by 3 to get 24, right? So you take 5 and you multiply it by 3, you get 15. And then you take 3 and you multiply it by 9. And you multiply it by 3 and you get 9. So remember, for Team B, to get it from the lowest, to get it to the common multiple, you multiply it by 3. And for Team A, you multiply it by 4. Okay, now to find the ratio of the total number of boys to the total number of girls. Remember, both your totals for Team A and Team B must be the same. 24 must match 24. That's the key here. Now you go boys is to girls. You take all the figures of the boys. 20 on team A, 9 on team B. So it's 20 plus 9 is to 4 on team A and 15 on team B. 4 plus 15, that will give you 29 is to 19. That is the ratio at the SCORE Campus Sports Day, and that is your final answer. Last question of lesson 4. Jason had some blue and silver marbles in the ratio of 3 is to 5. Then he got a little greedy and he went out and bought another 35 blue marbles and 13 silver marbles. Once he did that, the ratio of blue to silver marbles became 1 is to 1. How many blue marbles did Jason have at first in the beginning? So technically this is like a before and after question. So let's set it up by drawing a model using the given information. Step 1, before. Before we had what? 3 blue units is to 5 silver units. 3 blue units is to 5 silver units. So let's draw it up. We get 1, 2, 3, 4, 5. After buying more marbles, the ratio became 1 is to 1. This simply means that the number of blue and silver marbles is now the same. So we can add to the model in this manner. Let's add. So he bought how many? He bought 35. Let's write 35 in there. Right, and then he bought how many more silver? He bought 13 more silver there. Okay. So before we move to step 3, let's draw this little. Let's draw this thing this little thing over here. Okay. So you see that? That is what? 35 minus 13. Do you think that's right? 35 minus 13. Those two units, those two boxes can represent 35 minus 13, right? So from there we move to step 3. Now we can see that we can find the values of the 2 units, which means we can use these units to find the answer. So the value of those 2 units is 35 minus 13, which is equals to what? Which is equals to 22. So if 2 units is equals to 22, 1 unit is equals to 22 divided by 2, which is 11. So if 1 unit is equals to 11 before what we had at first, 3 units of blue marbles, right? So 3 units is equals to 11 times 3. 33 blue marbles is the final answer. Well done, guys. We've done all 5 questions. Let's move on. Students, I know this was a long class, but we've come to the end of it. Go and try out the quiz. Have a ball of a time. Go score.